Assalamualaikum. Sorry, the previous video was interrupted a bit, but I guess it's okay. I think we managed to finish our discussion on the one example on how to find local extrema by applying the second derivative test. What I plan to do now is to continue with another example of finding local extrema, but in this case, you have more than one critical point. So this example is basically taken from the slide itself. So let me just get the question, the example. So this is from okay, so let's say we are given this question. We want to find the local extrema of this function of two independent variable x and y, x to the power of 3 plus y to the power of 3 minus 6xy. So let me just, can we do all of this here? Yeah, why not? So step number one is, oh, sorry, where is my pencil? We need to basically locate the critical point. Okay, oops, I did not enable, so let me just why don't we just do it here? Okay, why don't we just do this one over here? And so our the function given to us is that we need to locate. So we have uh, oops, just then it takes a bit of time to familiarize myself with some of these. Okay, where is my, okay, let me just get the, so we have this f of x and y is given as, what is it? Where is it? X to the power of 3 plus y to the power of 3, and then minus 6xy. So the question says here we need to find the local extrema. Okay, so step number one, locate all critical points. So how to locate all the critical points? F sub x equals, so 3x square, there is no x here, so 0, and then we have x here, so minus 6y. Set this to equal to 0 and do the same for f sub y equals 3y square minus 6x, and set this to equal to 0. So from here, we have, we need to basically solve this simultaneously because we have x here, we have y here, we have two unknowns, and we have two equations. So use simple algebra manipulations. So whatever techniques that you want to do, I'm gonna, let me see, I'm gonna do this by substitution, okay, as suggested in the slide. So basically we're gonna have 3x squared equals 6y, and then my y gonna equal, so 3 divided by 6 is 0.5, or 1 over 2 x squared. Okay, so I'm gonna then substitute this here. So I'm gonna have 3, put everything 0.5 x squared, all this square again, minus 6x equals 0. So this would be 3, 0.25 x to the power of 4 minus 6x equals 0. So 3 multiplied with 0, so this becomes 0.75 x to the power of 4 minus 6x equals 0. And I want to solve this. I want to factorize this, but this looks a bit ugly. So I want to make this into a round number, into a whole number. So I need to multiply this by, multiply by 2, give me 1.5. Multiply by 4 will give me 3. So I'm going to multiply this. So basically multiply by 4. So this would be 3x to the power of 4 minus 6 multiplied by 4 is 24x equals 0. Okay, I just want to change this 0.75 into a round number, into a whole number, so that it is easier for me to factorize this. So now I can take out 3x, right? 3x is the common factor. So from the first term, I'm left with x to the power of 3. From the second term, I'm left with 8 equals 0. So now either 3x equals 0 or x to the power of 3 minus 8 equals 0. For the first one, okay, 3x equals 0 means x equals 0. For the second term, so I have x to the power of 3 equals 8. So x basically equals to the third root of 8, which is 2. So now we have 2. Okay, maybe I should change this color a bit. So we have x equals 2 and x equals 0. For x equals 0, okay, I'm just going to use this space here to find the corresponding y value. So for x equals 0, okay, I'm going to use this equation, right? Because it is easier, this one. So I'm going to use this equation to solve for my y. Okay, so here we're going to have the 0.5 multiplied with 0 square equals 0. So my y equals 0 for the first case. Second case, when x equals 2, so 0.5 multiplied by 2 square equals 0.5 multiplied by 4, which is 2. So in this case, my y equals 2. So here from the first step, we have two critical points that have been identified, which are, the first one is 0 and 0, right? X, y. And the second one is 2 and 2. Now, this brings us to second step. Second step is to find the second partial derivatives, where we need to find f sub xx, f sub yy, and f sub xy. Okay, so for the first one, f sub xx. So from here, we have x here. So 3 multiplied by 2 would give us 6x. And there is no more x here. And then fyy, f sub yy. There is a y here, but there is no y. So 3 multiplied by 2 is 6y. And what is our f sub xy? There is no y here. There is a y here. So negative 6. Negative 6. And then this brings us to step number 3, where we need to evaluate f sub xx multiply with f sub yy minus f sub xy squared, okay, at the critical points. Since we have two critical points, we're going to do them. We're going to deal with them one by one. So first of all, for the critical point 0 and 0. So what is our f sub xx when x equals 0? It is 0, right? So this would be 6 multiplied with 0. And then multiply with 6 multiply with 0 minus. Okay, and our f sub xy is negative 6. So be careful when you write this with the negative sign, especially square. So this equals 0 minus 36 equals negative 36, which is less than 0. So since this is negative less than 0, we can immediately refer back to theorem 2. So this is actually case 3, which is f of 0 and 0, which equals to, so when we put in 0 and 0, we get 0 equals 0 is a saddle point. Okay, now for the second critical point, for 2 and 2, so we have 6 multiplied by 2 multiplied by 6 multiplied by 2. I mean, we simply need to substitute x and y here, minus negative 6 squared. And this would give us, this is 6 multiplied by 2, 6 multiplied by 2. So basically 144 minus 36, which will give us 108. And this is positive. Since this is positive, then we need to evaluate f sub xx, which is 6. Evaluated 6x. So now evaluated at this critical point, the value of x is 2. So this gives us 12, which is positive. Since this is positive, we can conclude that, can we conclude? Yeah, of course, but you need to basically put this back into the original function here. So f, when x is 2 and 2, equals to 2 to the power of 3 plus 2 to the power of 3 minus 6, 2 and 2. So here we have 8 plus 8 is 16 minus 2, 4, 24, negative 8. So we can conclude that, so f of 2 and 2 at this critical point, which is negative 8, is a local minimum. Okay, so that's basically step number 1, step number 2, and step number 3. 1, 2, 3. Okay, in order to solve for the uh, when we want to find the local extremum for a function that basically have more than one critical points. So I hope the example is simple enough. You just perhaps need to familiarize yourself, do a few more examples, because there are only 3 steps involved, and they are not that complicated. Okay, they are not that complicated, and it should be easy for you to score, inshallah. So that's all for now. Thank you. Assalamualaikum warahmatullahi wabarakatuh.